Welcome to the video on tuned collector oscillator. In this video, I am going to discuss about two different types of oscillator. The first one is tuned collector oscillator. It is a one kind of LC oscillator, and the next one twin T oscillator. It is a one kind of RC oscillator. So first of all, we can discuss about this tuned collector oscillator. Okay. So here this tuned collector oscillator is a another type of LC oscillator. So we can discuss the circuit diagram. Yes, this tuned circuit, this tuned LC circuit, which is connected in the collector branch, and this LC circuit directly connected to the VCC power supply. So that's why it is called as tuned collector oscillator. And this resistor R1, R2 and RE, which can used to establish the proper DC operating conditions in this common emitter amplifier. So this secondary winding voltage, if the voltage drop act as a feedback signal, and which is given to the base of a transistor. So this transformer introduces a phase shift of 180 degree, as which was indicated in this dot actually, and one more phase shift can be generated by this transistor. So totally the total phase shift around this loop can be given as 360 degrees. So this oscillation will be produced, and also it satisfies the Barkasian criterion. So and let us see the final equation for frequency of oscillation. So the final frequency of oscillation equation can be given as f naught equal to 1 by 2 pi root of LC. And the main drawback of this tuned collector oscillator is, and this circuit becomes bulkier, so and this circuit cost is high. So this is the main drawback of tuned collector oscillator. And now we are going to discuss about the next oscillator is called as twin T oscillator. So twin T oscillator is here one type of RC oscillator, and this oscillator have only the resistor and capacitor components. So there is no inductor component in this twin T oscillator. So you can see the circuit diagram. In this circuit diagram is called it is called as twin T circuit, and it have two different T networks. So let me see the two different T networks. So first we can discuss about this tank circuit. Sorry, yes, this C and R, these two resistance and these two capacitance are connected in series. So it will form a one type of T network, and the next T network can be given as this one. Okay, so both of them to form a network, and this network is called as twin T network. So the circuit consists of three transistors. So this Q1 and Q2, so followed by the emitter follower Q3, and this twin T filter can be act as a notch filter, and also it provides the better frequency stability. So here this back to back connection, so this two transistors can be connected back to back, and this two transistors, this pair of two transistors are called as Darlington pair. So this Darlington pair circuit provides 180-degree phase shift, and the feedback network provides 180-degree phase shift. So the total phase shift around the circuit can be given as 360 degree. So 360 degree or 80 degree. Now we can see the final expression for twin T oscillator. Yes. So please the final frequency of oscillation expression can be given as f equal to 1 by 2 pi RC. So here we can show, we are showing the two different graphs. That is what the phase response, and this is called as a gain response. So this twin T oscillator or twin T filter is basically lead lag circuit, and whose phase angle varies between this plus 90 and minus 90 degree against the frequency. So this is the phase response of the twin T oscillator, and the gain response, this is what FR, resonant frequency. When F equal to FR, so this circuit did not produce any phase shift. Okay, that is what the concept of F equal to FR. So now overall the frequency of oscillation equation can be given as F equal to 1 by 2 pi R into C. So let me see the advantages of twin T oscillator. So this oscillator works very well at one frequency, and it has one drawback. The drawback can be given as it can adjust over a large frequency range. Thank you.